Good evening, everyone. This is Bill Breeden. We are going to talk about another constellation tonight. Let's get my notes out here. This is Constellation Tour number 14, and we're going to go over the small northern celestial hemisphere constellation of Corona Borealis, otherwise known as the Northern Crown. Corona Borealis is best seen between June and August, so it is a summertime constellation. And we have our Stellarium planetarium software set up for July 1st at 8 minutes after 10 p.m. And tonight we also have a waxing gibbous moon in the sky. So that's fortunate because we're also going to talk a little bit about eyepieces and fields of view. So we'll have time for that tonight because Corona Borealis is a small constellation, so we'll have a little extra time to discuss eyepieces. So we have this set up for a suburban sky, so there's a little bit of light pollution. So how do we go about finding Corona Borealis? Well, let's start by looking south, and let's look up a little higher in the sky. And let's try to find the star Arcturus. Now, if you remember how to find that, let's turn our attention over here to the Big Dipper. And remember how to find Arcturus. You follow the arc of the handle, arc to Arcturus. And once you find Arcturus, you will be able to use that to find Corona Borealis. And you'll notice that when the moon is in the field of view here, it does wash out even more starlight. So that's pretty realistic. So as soon as we look up a little higher and get the moon out of our field of view, it makes a few more stars appear, which we will need. Corona Borealis is not very bright, but it is distinct enough to find. So you've got Arcturus here. And if you notice, over here to the upper left of it, you've got another bright star in the sky. That is Vega, and that's definitely up in the summer months. So you want to draw a line across this large part of the sky here between Arcturus and Vega. And you will find the keystone of Hercules between them, right here. And then you will find another second magnitude star here that looks like it's part of a C shape or a crescent. That is the constellation. That's actually an asterism, but that's part of the constellation of Corona Borealis. So let's go over that again. You follow the arc of the Big Dipper's handle to Arcturus and find Vega in the sky off to the left of it. Draw a line between the two, and you'll find the keystone of Hercules, and you'll also find this curved shape here. And that's how you find Corona Borealis. So let's look at our constellation lines. And you'll see that Arcturus is right here. It's the alpha star of Bootes. It's Alpha Bootes. And then you have Vega here, which is the alpha star of Lyra. So it's Alpha Lyra. And just between the two, you've got the keystone of Hercules, and you have Corona Borealis, the Northern Crown. So that's a way that you can find Corona Borealis in the sky. So let's look at the boundaries. Corona Borealis is a small constellation. It's just what you see inside this red border here. And the crown is right here at the bottom right of that area of sky. So all of this encompasses the constellation of Corona Borealis. So Corona Borealis is a small, faint constellation. There are no bright stars. The one second magnitude star that you do see is called Alpheca, or Alpha Corona Borealis, and it is 75 light years from Earth, so it's not as far away as some of the other stars we've observed. So, since Corona Borealis is pretty small, there's only 2 double stars that we're going to go over, and there are no Messier objects. So let's take a little time to go over field of view. It's a concept that some people have trouble with. So since we have the moon in the sky, let's talk a little bit about field of view. Now, on all of my constellation tours, I always set Stellarium up to show you a field of view of 60 degrees. And that's because 60 degrees really shows about what your eyes can take in without any instruments. So you go outside, you look up, you're able to really see about 60 degrees of sky at once. And if you want to look beyond that, you usually find yourself turning your head. So we simulate that in the software by dragging the screen over. But the field of view, what we're doing here is we're really demonstrating true field of view, which is abbreviated TFOV. And so besides 60 degrees, most planetarium software will let you zoom out farther to even greater fields of view. Like right now, I have it at 163 degrees. This makes the software behave strangely, and it looks more like a planisphere at that point, and where you can see all of the horizons at the same time. This is typically what you would see published in magazines, showing you the sky tonight. Here's the Big Dipper. Let's see. Here's Arcturus. Here's Vega. So here's the Keystone of Hercules, and here's Corona Borealis. Okay, this is hard to visualize. It's too much sky. So if you're using planetarium software, keep your field of view at 60 degrees while you're panning around. Another very useful field of view that I use often on these tours is 6 degrees. And that is because that's about the field of view you get with most finder scopes and most binoculars. Now, some will give you a little more, 8 degrees, 10 degrees. Some will give you a little less, 5, 4 degrees. But usually not much less than that. So 6 degrees is a good way to simulate what you'll expect to see in your finder scope. Now let's talk about other fields of view that are important. These 3 rings here, these are called Telrad rings or Telrad circles. And the outer one shows you 4 degrees of sky. The middle one shows you 2 degrees of sky. And the inner one shows you half a degree across. And it's no small coincidence that the moon just fits inside that circle. The moon is about half a degree on the sky. So when talking about fields of view and angular size, you can always use the moon as a reference. So if something is 1 degree across, you know it's about from here to here. It's about 2 moons across. 1.5 degrees would be 3. So that would be from here to here and over to here. That would give you 1.5 degrees. So the moon is a really good reference for 0.5 degree. Now, while we're talking about fields of view, remember we're talking true field of view again. Let's put the moon in an eyepiece. And let's use a common 26 millimeter Plossl. And this is giving me, this 26 millimeter eyepiece is giving me just over the 0.5 degree field of view, because you can see some sky around the moon, and the moon is about 0.5 degree across. So this, even though we're looking through an eyepiece, you're still seeing just over half a degree here. So whether you're using the eyepiece or you're using a Telrad, this amount of sky that the moon occupies is half a degree. And how large it appears to you is based on magnification. So that's field of view. If that helps you, those three fields of view are pretty important to remember. 60 degrees for naked eye, 6 degrees for binoculars or a finder scope, and 1 degree or less, half a degree, for a typical eyepiece in a telescope. The other field of view term I want to go over with you real quick is apparent field of view, sometimes abbreviated AFOV. That one's a little harder to describe. Apparent field of view is if when you look through an eyepiece, how big does the sky look to your eye from one edge of the inner circle to the other? And that's hard to simulate in software because you really need to have your eye up to an eyepiece to get the field of view. So this eyepiece here, this 26 millimeter Plossl, is listed as having a 52 degree apparent field of view, which means that if you were actually at the eyepiece looking through it, the amount of sky that your eye takes in is 52 degrees. You're not seeing 52 true degrees on the sky. I mean, that would be huge. You're seeing an apparent field of view of 52 degrees. So in order to compare eyepieces, you really have to kind of concentrate on their apparent field of view. So this Plossl gives me a 52 degree. Now this is a 40 millimeter Plossl. It has an apparent field of view that's less. It's only 43 degrees. So I'm going to switch between the two. You see how that outer black ring grows and shrinks? That's the software's way of simulating apparent field of view. So one of my favorite eyepieces is my 24 millimeter Panoptic, and I've got that loaded in the software here. That has an apparent field of view of 68 degrees. So that's from here to here. When you're looking through the eyepiece, it gives you the impression that you're seeing 68 degrees presented in front of you, but it's magnified. So if you were to use another Panoptic, say a 19 millimeter, with the same apparent field of view, let me switch between the two. 24 millimeter, 19 millimeter. 24 millimeter, 19 millimeter, with the same apparent field of view. You see the outer edge here, the eyepiece didn't change. That's simulating apparent field of view. So hopefully that helped you understand the terms true field of view versus apparent field of view. And in these constellation tours, the only one that's really important and relevant is true field of view, because that's how much sky you're seeing. So I've returned back to our naked eye field of view, 60 degrees. And let's go ahead and look for these double stars. I'm going to start with Zeta Corona Borealis. So let's go back up and find Corona Borealis. Remember, we want to look for the Big Dipper's handle, and we want to arc to Arcturus, and we want to find Vega, and between them you'll see the keystone of Hercules, and you will see this crescent shape. This is Corona Borealis. So while we're looking for this double star, let's make it dark. Let's go out to a dark sky site. And now you can see here's Corona Borealis right here. And now let's search for Zeta Corona Borealis. Okay, let's look through our finder and get us a 6 degree apparent field of view. I'm sorry, I said it wrong. True field of view of 6 degrees. And this is simulating what you would see in your finder scope. And there's there's Zeta right there in the middle. So I can't really split it yet. Let's see what our eyepiece does. This is through our 19mm panoptic eyepiece with a 68-degree apparent field of view. And it doesn't look like it's splitting it. It looks like it might be a little bit. So let's put a little bit more magnification on it. See if it splits. There we go. So it took a lot of power to get it to split. So you might want to use, if you're going to try Zeta, you may want to use a shorter focal length eyepiece, like a 10mm or less. Okay, we've got one more double star to search for, and that is new Corona Borealis. Oh yeah, this is going to be a nice one. This one is already split nicely, and it looks like it's a 5th magnitude with a bit of an orange hue to it, which is really striking with all these other white and light blue stars in the background. So this one would be fantastic to look through, even through your finder scope or scanning the sky with a pair of binoculars. Let's take a look at it through an eyepiece. There we go. That's what it would look like through a 19mm panoptic eyepiece. That's a spectacular double star. This one is 650 light years away. So it's pretty far away. Okay, this concludes my tour of Corona Borealis, the Northern Crown. Good night and good seeing.